Okay, next we're going to hear from Professor Nate Hartman from the Polytechnic, from the Purdue Polytechnic Institute. Nate has put together a really fantastic team that, following on the theme that we've been talking about this afternoon in the second half, is bringing technology and, in this case, manufacturing to completely new realms and approaches of digital smart manufacturing. And again, I think these things all tie together in a sense. When you're doing manufacturing digitally with advanced technologies, what are the vulnerabilities of those? But anyway, Nate is going to tell us about the kind of work that he and his team have been doing on advanced digital manufacturing.
Thank you, Tomas. Good afternoon, everyone. As Tomas mentioned, we have a very diverse team who I noticed some of my colleagues are in the audience here, and I'll share some of that with you in just a moment. But I'd like to play a short video first. It's just a couple minutes long to kind of set the stage for the environment that our team was beginning to investigate. And so we'll go ahead and play that, and then I'll start in with a few slides to summarize some things after that. So that particular video, I think, summarized a number of things that we've heard already from my colleagues that have presented before me.
Now we continue our special look all
Whoops.
at the future of work.
Something like that. I probably ought to close that, but I thought minimizing might take care of that. But that being said, right. I think I may have also found a few potential collaborators, and my colleagues sitting up front here. We chose to take the view of looking at a particular industry sector with our project, and that was manufacturing. And we've heard many things about manufacturing over the last several years about, from its demise to its resurgence to where we are today versus where we might be tomorrow. And as I watched that video, the reason I picked that video is because when it comes to a manufacturing scenario, it included the design of things, the creation of things, the production of things, the movement of things, and then the customer taking possession of things, whatever that thing happened to be. And that, by and large, is what we've known historically as the manufacturing ecosystem. Now, obviously, there's more boxes to fill in between those major activities, but by and large, that's what we've known. And so with this new age that we find ourselves in manufacturing, digitalization has become the thing that's going to impact that the most. And so much of our project had to do with the two halves that our team saw of this, and the way that video ended was indicative of one of the halves of that particular paradigm that we were following, and that was, will our children be ready to work in an environment like this? Frankly, will people who work in that environment today be ready to work in an environment like this? And so literally one half, roughly, of our project to date has been about trying to understand the social, educational, and policy elements of that particular phenomenon. And so with that, I'd like to kick us off by introducing our team. I realize this is an eye chart, but when you look at this team, look at where these folks' areas of expertise are and where they come from, right? There's engineering, there's Polytechnic, there's social sciences, there's computer science, there's education, and a number of others. And so one of the, and I'll talk about this more at the end, but one of the things that I'm most proud of about this particular project as the person who got the opportunity to lead it was that this team, by and large, has remained intact throughout the project, and we have gone on to do other related things, which will ultimately be yielding benefits fairly soon. And so with that, we find ourselves in a situation, top half of this slide, 20 years ago, the idea was, how do we get more for less? Where is the value from manufacturing and from manufactured things? And much of industry's drive towards better and faster and higher quality and those sorts of things comes from this idea of more value for less. But pretty soon along the way, we began to wonder, where did some of those jobs go? What happened to them? And so those two questions are really what has been at the heart of our particular series of, our project and the things that we've done over these last 18 months or so. And in today's environment in manufacturing, we hear a lot about what you see here at the bottom of the screen, which is this notion of a digital environment or of a digital twin. Just out of curiosity from the audience, how many have heard that word before, digital twin? Right? And it begins to take on its own meaning, and it begins to mean a lot of things to a lot of different people. And many of my colleagues up here in the front row, as well as some of the folks who have asked questions, have touched on that particular topic, whether it be with data flows or sensing or what have you. It just so happens that in our project, it was applied to manufacturing as opposed to some other area of the economy or of society. And what we found, again, 20 years or so ago, we had economic benefits and competitive advantage associated with manufacturing and all of the economic and social and political advantages that it had, but yet we also had increased environmental waste, we had increased usage of resources, increased raw material consumption, and so we found ourselves kind of at this vexing conundrum, right? As profitable as manufacturing was, and as good as it was for economies, it also had some side effects that we had to figure out ways to mitigate. And so as we have progressed into this world, this Industry 4.0 kind of world that people talk about, we find ourselves being able to gather information, and David alluded to some of this in his presentation earlier this afternoon, is we have this information, right? We have these digital representation of things, and the tie back to the physical product is one that yields information that we can use. But the trick is, how do we use it? Okay? And so much of the rest of this presentation is going to focus on the how might we be able to use it. And it's going to focus at a few different levels, from an organizational level to a job level to maybe even an individual product level. So with that, we've all likely seen pictures similar to this. And for those of you who raised your hands when I asked the question about the digital twin, it's often this scenario that gets painted where you have a product, could be an airplane, could be a car, could be a toaster or a refrigerator, I suppose. And then there is the physical object, and then there is the representation, the digital representation of the object. And what do we do with that? And ideally, control and automation, information and insight, those all go with this idea of the digital twin. So we set about to trying to understand how these phenomena relate to this new smart manufacturing sort of an environment that we find ourselves in. Here's an example of a project that we did with a company that makes heat exchangers for vehicles. They were having a particular challenge with their process that heat the metal elements of this heat exchanger to the point of nearly melting such that they fuse together, and those happen in batches over time. And they have sensors on these big giant industrial ovens that gather data from various points during that process. And one of the challenges is they were not having the levels of quality that they wanted. And quality for them could also mean bad parts, bad components go out to the customer, which could arguably mean loss of property, depending upon what happens with the heat exchanger. Hopefully not, but it could mean loss of life. And so one of the challenges we had was to try to figure out, and to help them figure out, where are these quality escapes going? Now, this might seem like, gosh, we do this all the time, and we've done this already. Well, the fact of the matter is for this particular company in this scenario, and again, a few of my colleagues have alluded to this before, we found this rather sort of vexing conundrum in the sense that, in this case, control and safety were looking as if they should go together, but they really weren't. And so what happens in an industrial situation where you have a large, very high temperature oven doing things to essentially bake components together, what happens if that process doesn't do what it's supposed to do, right? Are there safety concerns? Are there quality concerns? Absolutely. Here's another example of a project that we've been working on with a more local manufacturer about tolerances for their machining processes. Now, for those of you that may know some things about manufacturing, there's all sorts of variability in the production process, right? And it comes from a lot of different places. But one of the challenges we have is that if we can't characterize that variability, we cannot accommodate our designs for it, we can't control our processes very well, and ultimately we have a certain level of scrap. Now, over the years, statistical processes controls have told us that we're probably going to have a certain amount of scrap anyway, but the point is we want to minimize that. Minimizing it for material usage, for energy consumption, for cost, but yet if we don't have insight or predictive capability into those processes, into those phenomena, then how might we be able to better adjust that process? Well, we can't. And so even though we can put sensors on a number of different things, and again, this has come up a couple times in the other presentations, is that even though we can have sensors on things and gather information from things, what do we do with that information once we have it? And one of the big challenges with this idea of smart manufacturing has been, can we make sense of the information to make better decisions in a timely fashion? Another area that we investigated was the way in which sensors were built, right? The idea here is that inline sensing of individual components is important. It's relatively easy, I suppose, at times to, once a component fails, figure out where it fails and then go fix it. Ideally, we don't want to have that scenario happen where we have to wait until something actually fails to be able to go fix it. You know, some commercial manufacturers tout, you know, refrigerators, ovens, things of that nature, will tell you when they need filters replaced or when they need clean, right? How many of you have cars that tell you your oil needs changed? Right? Well, that's based on a certain model. It's based on certain sensing capabilities, those sorts of things. And what we want to try to find are those problems before they show up, not after they show up. Now, what comes with this advent in technology, and in particularly its application to manufacturing, is a new skill set. And so our project, this is the second half that our project has focused on. So the first half was about deployment and connectivity between technologies in real manufacturing applications. The second bit of this has been, how do we get people, not just current workforce, but workforce that is in the talent pipeline, to be able to deal with these changes, okay? And as we think about this, think about a scenario where you have this level of skills, those levels of positions. And a lot of people, when they think about where do the jobs go, we see this hollowing out potentially of a middle. Now, there's a lot of economic forces, socioeconomic policy, those sorts of things that address this issue. However, what it still doesn't stop is the fact that we now have this gap, all right? And so what do we do about that gap? Because we only have a few different options. If this middle area doesn't train for these new things, they risk falling down here. Or this middle area, if you will, can train new and maybe take a new job that is created as a way of this digitalization phenomenon. Or arguably train up such that they reskill or upskill themselves to be able to compete and to be able to sustain in this new environment. And so as we think about things like this and contemplate things like this, and I'm not necessarily, and neither are my teammates, really advocating for or against. We're simply saying that if some of these things continue to evolve and continue to come to fruition and continue to be applied, how do we make traditional manufacturing environments look a little bit more like more consumer-oriented environments, such that people will want to pursue them as pursue careers in that space? We've all, I suspect, that have an interest in this community have read reports about how many unfilled jobs there are and how many of those we expect to have in the future. And so what we tried to do with our project is begin addressing things at the various levels, incumbent workforce as well as workforce pipeline. And so these last few things are going to begin looking at those. First off, we began to look about, why don't people choose manufacturing-oriented careers? Because if this pipeline is so important, and if this incumbent workforce is so important to have them retrained or upskilled, whichever label you want to use, why is it that people are having a problem doing this? It's not as if there aren't jobs available. There certainly are. But we have people choosing not to go into them. And so one of our colleagues on the team, Blake Allen, who's in sociology, began to look at what are some of the factors influencing choices. And so it's our opinion on the team that, you know, this may mean that manufacturers, companies, are going to have some choices to make, maybe some hard ones, about how they develop their workers and whether or not they deploy certain technologies. A second example, one of my colleagues from Cranert, Tom Brush, was looking at supply chains. Many manufacturing ecosystems have large, what we sometimes call OEM type companies, who have suppliers, right? And those suppliers give them component parts or services or what have you to go along with the finished product. Well, the challenge becomes, is the supply chain in that case as technologically adept as the OEM is? Most OEMs have the resources and the wherewithal internally to train a workforce. Many suppliers, who tend to be smaller companies, anywhere from a few hundred to a few dozen at times, often don't have the wherewithal to train their employees and to address those challenges. Not only that, Tom's looking at, does this diffusion of digital technology have an effect on a company's ability to do that? And so there are some promising results coming back from some interviews that Tom has done with some of our industry partners about what that means. And there'll be some publications coming out very soon. And finally, one of my colleagues, Greg Strimmel, who is in technology teacher education within the Polytechnic, this is the program that trains technology teachers for middle school and high school. Many of us may have known that as industrial arts, if you will, as when we were going through school, or technology education as we were going through school. Greg did and I realize that some of this text on here is a bit small, and so I'll summarize really the main point of this slide, is that we began looking at, and Greg's group did a fine job of this, the perception of manufacturing from kindergarten to second grade, and the perception from what's actually on the next slide of 3rd to 8th grade. The point is this, ladies and gentlemen, is that by about the age of 5 or 6, children begin to solidify in their mind what they want to do sort of when they grow up, if you will. And one of the things that we don't do culturally a very good job of is to allow them sort of the design and build creativity that leads them to many of these careers that might be associated to manufacturing. You know, for those of you who may have had children at that age, what is often one of the vocations they say they want to be? Teacher, doctor, nurse, firefighter, police officer. Why? Because those are really obvious things in their environment. They can make a connection with those kinds of roles in society. And so one of the things that our project and our team has found is that if we're going to make a dent in this workforce pipeline issue that the manufacturing sector, at least in the US, although I would argue globally, has a challenge with, we're going to have to expose children or students much, much earlier to these opportunities than we have in the past. And so Greg has some publications that will come out a little bit later this year that dives into much more detail than these infographics show. And so with that, what have been some of our accomplishments that we've done? So some of you may have heard about this thing called WIN, the Wabash Heartland Innovation Network. So members of our team contributed very substantially to the manufacturing side of that particular effort. And so what was nice about that is we had a ready-made group of people responding to that, and ultimately, as you know, Purdue and the Greater Lafayette Community Foundation were successful in securing almost $39 million from the Lilly Foundation to look at building a regional ecosystem around digitalization. There are some folks in the room who represent that group. We have an ongoing relationship, an emerging relationship, frankly, with the U.S. Air Force, the United States Navy, and Newport News Shipbuilding as it relates to this digitalization transformation that the Department of Defense finds itself going through. The interesting bit about that is the DoD doesn't manufacture anything. They spec it, they design it, they have somebody else go off and make it, and then they take possession of it. And so that presents a particularly vexing challenge for them, because a lot of times once they take possession of it, information, digital artifacts in particular, need to make their way into the hands of people who have had no idea how this object was, whatever it may be, was designed or made. And so how do we support it and how do we sustain that? And so what we're working on with them is an educational program and an assessment program to accompany that, that'll try to determine where their personnel's digital literacy is from, again, from sort of a design and manufacturing and sustainment perspective, and ultimately craft education to be able to support them. Partnership with Greater Lafayette Community Foundation in placing maker spaces into elementary school, as well as looking at the vocabulary that those children use. In many cases, when you go into a manufacturing facility, what's one of the first things companies often ask you to do? Don personal protective gear and watch this video about all the ways you can die in this factory, right? And so if you give that same speech to a 7-year-old child, what do you think their reaction is going to be? Well, heck no, I don't want to work here, right? So one of the things that Greg and his group is researching is how do we change the dynamic by which we present this important thing to younger students. Moreover, with the maker spaces, how do we present math and science skills that these students are going to need in a digitalized manufacturing environment in the context of designing and making? This particular project is really exciting, and I apologize, I know I'm over time, but what we've got is a makerspace actually out at an elementary school in Tippecanoe County here with desktop design tools, desktop CNC tools, desktop robotics, all right, desktop 3D printing. And the idea is we're working with a group of teachers that'll have a curriculum ready to pilot in the fall, okay, this coming fall of 2019, that will teach grade school level Indiana math and science standards to children in that school, actually several schools in Tippecanoe County School Corporation, through the context of designing and making. And so we're pretty excited and pretty bullish about where the results of that goes. Finally, we have a cohesive team now that we feel like can respond to much greater opportunities as it relates to manufacturing, because that team has remained intact. And finally, this idea of establishing, some of you may know the Indiana Manufacturing Institute out in the Research Park, but the Big Idea Challenge project, along with some support from these various groups, are allowing us to create a test bed. Basically, it is a scaled down version of a factory to support the research of digital product and process data through an enterprise and how that works. And so with that, I'm going to say thank you all very much for listening, and I appreciate the opportunity that Discovery Park has given us. Thank you.
Thank you. Thanks, Nate. Perfect. Okay. What a great example of the total being bigger than the sum of the parts. When you bring all these people together and look at these really complex problems of the future of work and manufacturing from these different perspectives. Very, very exciting. Questions from the audience for Nate? So maybe I'll ask you the first question. What I got left with from the video, and I thought maybe you were going to go there, was, well, who is going to work in these plants? Are they all going to be automated? I mean, is your team thinking about that, the future of work, from the perspective of, what skills are we going to need, and how many?
Yes, we are. In fact, I've noticed some of my colleagues here, Jim Greenan, Greg Strimmel, I see Tom in the back. We've gotten into a number of discussions about this. And this is one of the things that I think a lot of folks who write, commentary or op-ed sorts of pieces in this space have done, and other larger companies, the McKinseys, the Deloittes, and Accentures of the world, done some studies on this. And where the data is really coming out is that in many sectors of manufacturing, or in many manufacturing verticals, it may be a little while yet before a lights out factory is really where we are. And in many cases, what may look like a lights out factory is actually a factory that may be highly automated, but yet we still have people who are either controlling the process, designing and writing code, or implementing machines to run that process. And frankly, what is still, I think in many cases, not quite known yet, is how do we maintain and sustain, let's say, a factory that is highly automated, right? Professor Zhu, in his comment about, you must sort of reiterate and refine that security model. Well, arguably, you must reiterate and refine that automation model that goes into your factory as well. And whether that's changing product, whether it's changing an entire line, whether it's changing around the entire factory. But I think, Tomas, what we're going to see is a much more configurable environment than we've traditionally seen in the past. But I don't know that, at least in the foreseeable future, it's going to be one that has too many fewer people.
Okay. Thank you.
Yeah.
Young?
Yeah.
Comment, must
Yeah.
my three children all
Hang on. Grab the microphone.
right. common question. My 3 children all want to become paleontologists when they watch the video like Dennis Train or whatever.
Yeah.
I'm sure when after they watch like the Boston Docks and walking around, maybe they want to work in a manufacturing engineer, something like that, or be a hacker. So there's all these scary scenarios that both your talks kind of sort of. So this relates to one of the topics we actually discussed in the workshop on AI, I think in the fall. If with all these automation that's also mentioned, the artificial intelligence, machine learning play increasing role, that they not only can, make things, but develop tools and starting develop, create some kind of creativity. Now, how do what's your thoughts on actually kind of start to think about bigger picture of not just children, maybe the grandchildren, the role of the human intelligence in some sense, that we start to think about the education from early age. I mean, when 30 years now, the intelligent AI will play even much bigger role taking a lot of things, as a question, everything will be a lot of things will be automatic. Then what do they do?
It's a really interesting question. I guess I would answer it this way. When we think about life expectancy of all things, there's articles out that say now a person born today is going to live to be 100 years of age. Now, whether they do or not, I suppose is somewhat debatable. But if people begin to live to 100 years of age, right? I remember when I was going through school, people said be prepared to have 3 or 4 different jobs over the course of your career. But if somebody lives to be 100, is it conceivable that they may have 3 or 4 careers over their lifetime? And so I think what we need to begin to do is educate students, and not just educate them in the traditional way of sitting in a classroom, but also educate them in much more informal settings as well about things like data literacy or information literacy, things like computational thinking, things like systems thinking, things that, and even the more effective domain or affective domain about communication, right? And about skills that are less cognitive and maybe a little more hand-based or a little more heart-based, arguably, right? And so one thing that likely will never go away is the ability and desire of humans to interact with themselves, right? To be able to have a network of people come together to, whether it's create or whether it's solve a problem. So I believe we need to give them educational opportunities that allow those sorts of things in as much as they also allow the more formal and formative things that we do with education.
Besides being a member of the faculty, I'm also involved in production agriculture. I was helping a former student of mine because she'd lost her father to cancer this last year. So I was running a 500 horsepower tractor this fall, state-of-the-art GPS. The problem was not the diesel engine. The problem was not the transmission. The problem was tech support from the dealer, because I lost the signal from GPS to the satellite out in space. And they literally came to the field with a laptop and a hotspot trying to trace the wiring harness on a $500,000 piece of machinery.
Yeah.
And so my point is, we really need people not only in the design and the manufacturing, but also all kinds of software and tech support as you go forward. And I think that's where there's going to be some job creation. And some of those I think will be university trained, but some may be Ivy Tech or other kinds of opportunities. So maybe you might want to comment on that.
So I think you raise a very valid and very interesting point. I think contrary to my chosen profession right this minute, I'm not necessarily somebody who believes that everyone needs to go to college in order to be successful. That being said, I think what we can do as universities or as two-year colleges or even in high school, middle school, and elementary school is I think we need to give students the latitude to solve problems with not just the tools of the day, right? The tools of our time, if you will, but give them the ability to create additional tools in a very ad hoc manner as they need to in order to solve a problem. To teach open-ended problem solving, right? As a formal instructional thing, right? I watch my own children as well. I have a freshman in high school, I have a middle schooler, and I have an elementary schooler as well. And some of the things that I watch them doing, they still learn their multiplication tables, if you will, but they learn them in a far different way than most of us in this room probably learned them, right? They still learn how to do algebra, but I suspect in a much different way than most of us learned how to do it. And I guess what I would finish with in terms of answering that is that I think we as a society maybe need to change our mindset a little bit about what it means to be able to contribute value and what it means to be able to be a productive and contributing member, if you will, of society. I suspect that individual that showed up, from either the tractor manufacturer or the dealer that supplied that tractor, I suspect that individual was rather well paid. And and I suspect that individual, probably had a little bit more education than just a high school diploma. And so what I think we need to do is begin thinking about those things that may potentially be automated or compartmentalized because of technology, but begin to learn to work with those things almost the way we learn to work with Lego blocks, right? There's, ones that have, 2 and 3 and 6 and 4 and 8, right? And they come in those increments. Well, we can learn to increment, to some degree, technology as well. And I don't want to say that we necessarily take it for a given, but what I think we need to do is be able to get people to understand that, there's a certain amount of intelligence arguably embedded in that technology. So how do we deploy that in an effort to solve our problem?
Thanks very much, Nate. Terrific.
Thank you all.
Okay.